Hi, I'm Tom McGrath, and we are doing a tennis ball experiment. Our problem is, how does the density of certain liquids, affect the buoyancy of this tennis ball? Our hypothesis is, if you increase the density of the liquid, the better the ball will float. Our test one is water, which has a density of 1 gram per centimeters cubed. Right now, to figure out how well it's floating, we're going to find out the depth of the tennis ball, which is how much of it is actually underwater. As you can see, the ball is about 1 inch underwater, which converts to about 2.5 centimeters in the metric system. We will now conclude this experiment and move on to a more dense liquid, salt water.
Moving on to hydrogen peroxide. The hydrogen peroxide is 1.4 grams per centimeter cubed, and now we're going to immerse the tennis ball inside the hydrogen peroxide. Okay, the tennis ball is 1.9 centimeters immersed into the water, and this concludes that the tennis ball is less immersed and more buoyant inside the hydrogen peroxide than the salt water.
Our gasoline experiment, and gasoline has the lowest density of all the liquids we've experimented with. And when I put the tennis ball in, you can clearly see that it floats to the bottom. And this ball sunk the most out of any of our experiments, which means that gasoline is the lowest density of all the liquids.
This experiment is called Girls in a Pool. This experiment will demonstrate how volume affects the buoyancy of an object. We'll be using a pool and a few people. They will first take a deep breath to increase their volume as much as possible, and they will float in the pool. They will then release all the air in their body, decreasing their volume and thus sinking. They will first demonstrate floating. They will now demonstrate sinking by blowing all the air out of their bodies. As you can see, the greater the object's volume, the greater its buoyancy, and the less volume there is, the more it'll sink. And that's the end to the experiment of Girls in a Pool. Hey, Omid, all the scales in the world are gone. How can we figure out how much this egg weighs?
Ladies and gentlemen, this is Mambo number 5.
The answer is in the buoyant force. Archimedes' principle states that the buoyant force of an object is equal to the weight of the fluids displaced.
Ladies and gentlemen, this is Mambo number 5.
Inside the water, see how much water gets displaced into the pan. Now we're going to weigh out how much water is displaced, not counting the pan. And the water displaces 50 grams. That concludes that experiment. Right, we're going to put the egg to see how much it weighs. And we were a little off, we were off by 2 grams. The egg weighs 48 grams. And the water displaces 50 grams.
That's right, Carter 3, come on. Yeah, yeah. Walk with me, come go with me. Yeah, it's Lil Weezy, baby. And I'm just lighting up my. Yeah, yeah, yeah. 1-7, cash money, young money. Born in New Orleans, raised in New Orleans. I will forever remain faithful, New Orleans. I thank you, New Orleans. Thank you, Holly Grove. Has been my hood since a snotty nose. I come through the hood, suicidal doors.
The Empire.
Come through